The notes for Unit 4, Lesson 3 cover sig fig math. So when you are doing certain calculations, you have to pay attention to how many sig figs each of the measurements are that go into the calculation and round your answer appropriately. So make sure you have your notes packet. Also make sure you have a calculator because we'll be doing some calculating. All right, here we go. So first, I want to go over why are we learning this. So for example, later on in this unit, we will calculate density. So the formula for density is mass over volume. So say we were finding the density of these nails. Okay, here's our mass. So we have a mass of 30.0 grams. And if we look at our volume, we would measure a volume of about 67.3. So remember, the 6 and the 7 in this value are known digits. So we know 65, we know 66, we know 67, we know 68. So we know, values to the, let me rewrite that. We know values to the tens spot. So we know values to the 10 spot. So we have to estimate one decimal place past our known values. All right, so then this is going to be milliliters. So in your calculator, if you take 30.0 divided by 67.3, you get a number that looks like this. Okay, so my density cannot be this precise because the measuring tools that I used to find it weren't that great. So our answer can't be that precise. So we have to round our answer to show that we used this scale and this graduated cylinder. So if we were rounding our answer, and we'll get to this in the notes, when you divide, you actually have to use the number of sig figs. So our first measurement, 30.0, has 3 sig figs. So I'm just going to put a 3 over here in parentheses. And then 67.3 also has 3 sig figs. So our answer needs to be rounded off to 3 sig figs. So when we take this number and round it, we'll keep the 4, we'll keep the 4, we'll keep the 5. The 7 is going to cause that 5 to round up. So our final answer would be 0.446, and then we would add the unit grams per milliliter. So this would be a more accurate value for our density because that shows that the measuring, it shows and takes into account how precise the measuring tools were used to guide this calculation. All right, here are your rules for when we do sig fig math. When you add and subtract, you round your answer, so the result must be rounded to the least number of decimal places as each value in the calculation. So when you add and subtract, you round your answer to the fewest number of decimal places. So if you had this example, 4.77, so again, now you have to be careful because now we're looking at decimal places, not sig figs. So this number has 2 decimal places. Whoops. All right, it's hard to read, sorry. 1.0 would have 1 decimal place. 234.0 has 1 decimal place. 12.0111 has 4 decimal places. So out of all of these numbers, the least number of decimal places is going to be 1. So we have to take our answer and round it off to just 1 decimal place. So we would round it to the 10th. So that only applies when you're adding and subtracting values. When you're multiplying and dividing, now you take your result and you round it to the least number of sig figs as each value in the calculation. So when you're multiplying and dividing, you round your answer to the least number of sig figs. So if you have this following example, 3.22 times 0.094, If we look at this first measurement, this has 3 sig figs. This second measurement, these are leading zeros, so those do not count as significant, so this would have 2 sig figs. So SF, I just abbreviate for sig figs. So our answer has to be in 2 sig figs. So we would take our final answer and round it off to 2 sig figs. So again, when you're adding and subtracting, you look at the least number of decimal places. When you're multiplying and dividing, you look at the least number of sig figs. All right, so these should be examples in your notes. I want you to pause the video and try these out on your own. And then you can unpause the video and double check your answers. All right, so I am just going to write the full answer that I get in my calculator when I do these calculations. And then I will round, whoops. So these are just the regular answers from the calculator. These are not incorrect decimal places or sig figs quite yet. Okay, so I'm going to switch colors. So the first one we're subtracting. So when you subtract, you go by least number of decimal places. So the first number has 1 decimal place. The last number, or the second number, has 4. So we're going to round this off to 1 decimal place. You always want to look at the next number to see if that if the 3 would cause the 6 to round up, which in this case it doesn't. So my final answer would be 51.6. All right, number 2, we are multiplying. So now we have to go by least number of sig figs. So in this first value has 2 sig figs. The second value only has 1 because there's no decimal place. So the least number of sig figs is 1. So I need to round this off to a whole number. So again, I look at the next number to see if the 6 would cause, if the 2 would cause the 6 to round up, which it won't. So 6 would be my final answer for that example. All right, number 3. You are subtracting. So again, with subtraction, you go by least number of decimal places. So here's 1 decimal place. The second number has 2. So we want to round this answer off to 1 decimal place. The 1 will not cause the 8 to round up. So we are going to end with 81.8. And my last example, you are dividing. So when you're dividing, you go by least number of sig figs. This first number has 2 sig figs. The second number has 3 sig figs, so 2 is going to be the least number. So then I'm going to keep the 12, but I have to look at the next value. The 5 is big enough to cause that 2 to round up, so I would round up to 13. All right, as always, let me know what questions you have.